we're on the cusp of a white-collar bloodbath.
This is not everyone's not going to have a job and just robots are going to be running the world.
Does that mean you're not going to hire anymore?
There's lots of jobs, and in general, the economy is much bigger, and on average, everyone is better off.
If you did decide to build kind of a competitive top-tier frontier model, the relationship with Anthropic or with Meta would change.
From the very beginning, we knew that people would be building on top of us. Sometimes those would be in conflict.
I want to just touch on the Annapurna acquisition.
Yeah.
Because I think maybe it's slightly underappreciated outside of...
Not by me.
I'm for sure. That's what I want. How much would you say of AWS's code is written by AI right now?
Over 80% of our developers are using AI in their workflows.
Do you recommend engineering as a career?
If you spend all of your time learning one specific thing and you're like, hey, that's the thing I'm going to be expert at for the next 30 years, that's not going to be valuable 30 years from now.
Matt, thank you so much for joining me. I appreciate it.
Yeah, thanks for having me on.
Yeah, absolutely. So I wanted to talk first about the future of work and white-collar work. There's a large spectrum of folks who either believe kind of we're on the cusp of a white-collar bloodbath all the way to utopia. Where do you fall on that spectrum and why?
Yeah, I think like in the technology world, there's never been a more exciting time to be in technology. And I think across industry, I'm on the much more optimistic side. I'll start there. I think a bunch of the advances that we've seen in AI and technology have an enormous potential to increase the efficiency and effectiveness and enablement in work. But I think a lot of where the technology promises to do is take away the toil of what a lot of people do in their day-to-day jobs. So I think if you look at a lot of white-collar jobs today, the vast majority of things that people spend their time doing is not the things that they would ever tell you they get excited about for their job. It's not putting my numbers into this particular system or pulling the report together so that I can report on the thing that I'm doing, or trying to collate a bunch of information so that I can actually understand what it is that I want to work on. That's a bunch of the work today but it takes up a large percentage of the time. And so my view is that AI can really help with that. I think people would love to spend more of their time on that creative aspect, on driving the aspect, on doing interesting analysis, on doing the parts of their job that they love and not the parts that they don't. And so today, though, it's necessary. It's a necessary part of almost every job, your job, my job, lots of other people's jobs. And if we can shrink that part down and give people more time to focus on the things that they're excited about, it drives value for companies, it drives value for people. And I think people will enjoy their jobs a lot more. So I'm very optimistic that this is not everyone's not going to have a job and just robots are going to be running the world. I just think that's probably not the place that we're going to end up. I'm much more optimistic that companies can be more efficient, people can be more efficient, and people can spend more time on the things that they're excited about.
So I'm also optimistic. So I'm very glad to hear you say that. And I think a lot of people think, okay, if you're automating large swaths of people's tasks, day-to-day tasks in their job, you can do so much more as a company. But then does that mean you're not going to hire anymore? Like, how do you think about hiring in this future where every single person on your team is so much more productive?
Yeah, I think it's going to depend. I don't know that there's any one particular answer for any particular company. But look, if you look over the history of industry, there's been massive amounts of efficiency gains. And in every single one of those transitions, there's transition time. And I think one of the more critical things is for people to be flexible, to be willing to learn, and be willing to accept that their job may be a little bit different, and the components that they do of their job may be a little bit different, and that the job that they had 2 years ago is not necessarily the job exactly. The components of their job won't be the one that they have 2 years from now. But there's not like there's mass unemployment in the world today because we have computers and because we have automation and because we have robotics. There's lots of jobs. There's actually people that have higher paying jobs. And in general, the economy is much bigger, and on average, everyone is better off. And so I think that that's how you think about it, is that not that, there used to be, the silly examples are, lots of people used to spend lots and lots and lots of their time doing calculations. Now that we have Excel, it doesn't mean that a bunch of people are out of jobs because there's like a math engine doing all of the work. Yeah. You just assume, that's the tool that does it. And I think that is a good analogy. AI is a very different technology. It's much more disruptive than something like Excel, but it's an analogy where that was a job. There's automation that came into play, and now people do more higher value work. And I think that is exactly what's going to be true today. And it's a world that I'm excited about, but it does mean that people are going to, I'm not minimizing that uncertainty that people will have. And I know people are worried about it. And I think one of the things is embrace that technology. The more you can embrace that technology, be flexible, understand how it can help you do your job faster and better, I think the better off people are going to be as they make that transition, because it is going to be a really powerful technology for how, and I tell our teams all the time, I think AI has the potential to transform every single industry, every single company, and every single job. But it doesn't mean they go away. It has transformed them, not replaced them. And so it really is every single one of those. If you don't lean in and take advantage of that technology and learn that technology, then you might be out of a job, actually, if you don't really think about it and lean into it. Yeah. But if you do and realize how it can make your job better or faster, or you better or faster at your job, and frankly, push you to do more of what you might like to do, I think that's a world where companies are going to be better off, people will be better off, and there will be economic growth.
Yeah, and there's been a number of historical examples of world-changing technology. Right. And I think the pessimists will point to, well, the speed of change that AI is affecting right now is very different from previous technological shifts.
Right.
So do you think the speed is going to really affect the white-collar market? Do you think that's the differentiating factor compared to previous technological shifts?
I think the speed is, it is, I mean, this is a really rapidly evolving technology space, and people are just going to have to move faster with it. And so that is, look, I'm not minimizing, that's a challenge. People are going to have to move with it and embrace that. I'll use an example for your audience, from a developer audience. Developers, I've heard from developers worried about these coding tools are somehow going to make developers not needed anymore. And what I would say is, my view is, we're going to need more software developers, not fewer software developers. The job of a software developer may be a little bit different. I don't know that, archetype of a software developer that stays in a basement and codes by themselves for, weeks on end. I don't know if that's the job.
Yeah.
But we're going to need somebody who really knows software. We're going to need lots of people who know software, where they might have agents that can actually go and do some of the coding. In fact, I do think the part of the job that you probably are not going to have to do 2 or 3 years from now is authoring Java code. Like that is probably not a job that's going to exist, because these tools are going to be really good at authoring Java code, deconstructing a problem, deciding what to go in and build, pulling it together, looking at the Java code that comes back and deciding it's not quite exactly what you want, and you have it go and have agents go do that, coordinating a bunch of agents. That is going to be more a job that a software developer is. And that person is going to be able to drive so much more value because they're enabled. Like, how many times have you been frustrated at the speed of your own brain and how fast it is to actually do something?
Yeah,
you can think of ideas, you want to go do it, you want to actually put them into action, and it just takes a long time to do stuff. If you can kind of unlock that ability for creative people to go solve problems and develop interesting applications or interesting results, the amount of the value of having somebody that's good at that is much higher. Why would you want to get rid of those people? You're very excited about having more people that can do that. Now, you have to have people that can transition into thinking about how they use these tools. But, my experience is that most people kind of, once they get over that initial hump, actually quite get excited, because it is really enabling. It does actually enable you to create and go build faster.
Yeah, probably also the mindset of a business leader like yourself. You're looking at somebody and all of a sudden they are 5x, 10x more productive. The last thing you're
I don't want to get rid of that person.
Right.
I need
less of that type of
Yeah,
no. You want to invest even more heavily, because the ROI on that dollar comes back tenfold.
So it's just I don't understand the math of why we would want fewer of those people. So yes.
Okay, I love the optimistic view. Let's continue on engineering specifically. How much would you say of AWS's code is written by AI right now? And maybe define what written by AI is, because that can change depending on who you're talking to.
Look, I think for a while, for the last year or two, people have been excited about bragging about the number of lines of code that have been written by AI. It's like a silly metric. Like, okay, I bet it can actually write infinitely more lines of code. They might be bad code, by the way, but if that, it's not really the
measuring lines of code.
Yeah, measuring lines of code has never actually been the best metric. Yeah. Oftentimes, fewer lines of code is way better than more lines of code.
Fair.
So I'm never really sure why that's the exciting metric that people like to brag about. For us, I would say the last metric I saw was something like over 80% of our developers are using AI in their workflows in some way, right? And sometimes it's writing unit tests, sometimes it's helping write documentation, sometimes it's writing code, sometimes it's kind of an agentic workflow where we have something like called QCLI or a Nukiro IDE that allows them to actually have agentic things going and writing and collaborating with them. And that number is going up every single week. So I admit that I may not have the latest number, but it was north of 80% of our developers are using AI in some way, shape, or form to go build whatever they're building for Amazon customers.
Do you find that the engineers are proactively seeking how to upskill themselves and use these new tools, or do you also have educational processes in place and programs that help them?
Yeah, it's both. I mean, Amazon is a very large company, and so we don't have a homogenous set of employees. I think the vast majority of Amazon developers are curious, though. And so I think the number of them who have not used an AI coding tool is zero or rounds to zero. Figuring out how many are really using it to completely transform their job just to use it as some of the pieces, I think that is where education is also important, because I think there's some number of our employees that have really dived in head first and actually understood what works, because there is some learning curve there. It's the kind of understanding how you change work, what are the things that you do that can actually really accelerate versus slow you down. There's plenty of examples where you can be using some of these, first generation coding tools, and you kind of get down a rabbit hole, and it's actually quite hard to go back, because it's like actually a very linear process where the tools are kind of, when you're doing your vibe coding, they're giving you the code and you're like, that's not what I want to do. There's not like an easy way to go back to here. It's like, this is now the code you have. And so you had to just do it again.
This the other day.
Yeah. With Kiro, and part of what we've done in the agentic coding first kind of mentality is that you actually start with a spec of the thing that you want to build, and then you work with the tool to actually go and build parts of that spec. And as you're vibe coding, it can automatically change parts of that spec, but you still have that spec as the core thing you can always go back to and change aspects of it or functions of it or whatever it is. And we have seen the light bulb go on, because it actually, one of the cool things about that is that you can actually guide more junior developers as to like, what are great coding practices? How do we think about this? And so one of the things I actually am very passionate about, I was in a group, a leadership group, and people were telling me, they're like, we think that with AI, we can replace all of our junior people in our company. I was like, that's the dumbest thing I've ever heard. Like, they're probably the least expensive employees you have. They're the most leaned into your AI tools. And like, how's that going to work when you go like 10 years in the future and you have no one that is built up or learned anything? And so it's, my view is like, you absolutely want to keep hiring kids out of college and teaching them the right ways to go build software and decompose problems and think about it, just as much as you ever have. And so part of the benefit of some tools like Kiro is it actually can guide you into some best practices and kind of really learning how you construct and actually work together with maybe some of your more seasoned engineers who can kind of teach the right ways of going and building some of these systems.
Yeah, I mean, one of my questions was going to be, do you recommend engineering as a career to somebody who is entering college, in college?
Yeah.
I think I know the answer to that.
Yeah. My take is, when my oldest is going into senior year of high school, and first of all, the kids should go and study whatever they're passionate about and learn. But what I would say is, sometimes a lot of the skills that I think that should be emphasized is, how do you think for yourself? How do you develop critical reasoning of solving problems? How do you develop creativity? How do you develop a learning mindset that you're going to go learn to do the next thing? Because with the pace of technology that's advancing right now, if you spend all of your time learning one specific thing and you're like, hey, that's the thing I'm going to be expert at for the next 30 years, the most thing I can promise you is that's probably not the thing you're going to be like, that's not going to be valuable 30 years from now. But if you learn how to learn, or you learn how to think, I think that's actually where schools can be incredibly valuable. I think engineering is really great, not at teaching you the blocking and tackling of the specific thing, but really kind of how do you think and how do you decompose problems? And I think that's where kids coming out of school, if they really focus on that, then you're going to be in great shape.
And so when you look internally at your engineering organization, how do you measure success with respect to using artificial intelligence?
Yeah, I won't pretend that we have kind of that magic measure today. I don't know that it's any different than it was before. Some of it's productivity. We are still trying to learn best practices as the technologies are changing. And so we encourage experimentation. We encourage people to be testing different tools, different methodologies. We're also experimenting with different setups. Like sometimes, one of the interesting things is that when you used to have to go build a really large, complicated system, you needed a lot of people because everybody could focus on their one little piece.
Yeah.
one of the cool enabling things about this technology is you can have a broader vision or a scope over what you're driving. And so what we're finding is a lot of times we would prefer to have more smaller teams that are focused on problems. And actually you can kind of decompose these products into areas where there's really these focused teams that really go after something. And that small team can operate really fast. I know you were at a startup before. One of the benefits that startups have over big kind of enterprises is you can move fast. Well, that it's not like a inherent thing that you have to organize in a different way. Part of what we're learning is these tools enable you that even in a large organization, you can organize in small pods of people that can also move really fast. And if you can move fast and the tools enable you to move fast, you can go deliver outstanding things for our customers. And we think as even a relatively large business, that's going to enable everybody to move faster.
Okay. So let's switch topics for a second. I want to talk about capacity and infrastructure build out. When you are thinking about the next 2-5 years from now, what are the bottlenecks for your infrastructure build out? Is it the silicon? Is it the energy? What is it?
Yeah. When I was in business school, we were at a book called The Goal. Did you ever read The Goal?
No.
Okay. It's an old book. But the idea is when you're optimizing a production line, there is not like one bottleneck. There is a bottleneck until it's solved, and then the next thing is a bottleneck. And in many ways, like that is this thing. Like so, all of those are bottlenecks at some point. And I don't think that there's one thing. I just and there will just be a next one. And so you have to solve all of those things. I don't think there's one that's like, okay, if we have an infinite number of chips, there's no problem because you will need power. And if you have an infinite number of power and you don't have enough, networking devices, that's a problem. And so you have to have all of those pieces. I think one of the challenges is the challenges and opportunities for us as an infrastructure provider and a cloud provider is the opportunity is massive. And so there's a lot of need for compute. There's a lot of need for electricity. There's a lot of need for servers and chips and HBM memory and networking devices and disks and all of those pieces. And so the shortage for sure for the last couple of years has been in NVIDIA chips and chips in general. And I think as that eases, you're going to find that it may be power and it may be chips again. It's really hard to get all of these things exactly in sync to the growth. And because a lot of these things require lots of capital to go invest in. So our job is to think about all of those. And so we think 1 year out, 3 years out, 5 years out, how do we make sure that our customers, our business and our customers have enough power to support the things they're looking for? How do they have enough access to a broad swath of capacity that they have access for? How do they have network connectivity that they're going to need? And that requires us to think about, what are the amounts of capacity that people are going to need that many years out. Sometimes we're wrong and sometimes we don't have enough, but that's part of what we try to take on for customers. So everybody doesn't have to think about all of those things.
Yeah, I'm sure like part of planning the infrastructure build out is understanding where the usage is coming from. And so what are you seeing in terms of growth? Is it reinforcement learning? Is it inference? Is it training? Where is the most growth coming from?
Well, I think the most of the growth today is, at the end of the day, it comes from inference, right? And so it's customers using the end product. And so everybody likes to talk, like it's fun to learn about all of these new techniques of model building and whether it's reinforcement learning or fine tuning, but the vast majority of the usage actually comes from the end users, right? It is the inference of the end result. And then there's a bunch of pieces that go into how do you create better and better models that are cheaper and more efficient to use, more capable, more cost effective, all of those different pieces. And that is in that other bucket of great. We have a bunch of startups that are very focused in this space. We have a bunch of larger companies that are thinking about how do I create custom models and put a bunch of models together. But the vast majority of compute is frankly driven by that. Once it's all put together, customer comes in and asks a question or interacts with an application or tries to run a workflow or something like that. And that's what's driving the most of that usage. But we're focused on all of those pieces. And I think there's, from an infrastructure or power perspective, it doesn't really matter. Like the computer doesn't care if you're using it for reinforcement learning or for fine tuning or for inference, frankly. Most of these platforms are actually converging. There's some differences around networking that you might need for big pipe.
Like the same silicon can serve all of these different needs?
Yeah, absolutely.
Oh, interesting.
Absolutely. Okay. And so we're building Trainium, as an example, is a a great platform for, we're bad at naming, but it's a great platform for inference and for training, as it turns out. And that's true for many of the NVIDIA chips. It's the same set of servers that are great for both.
Let's keep talking about custom silicon, because I think
Sure.
that's obviously a huge differentiator
Sure.
for you guys. Like when you think about your own custom silicon, what sets it apart from competitors like Google's TPU, for example? Is it the cost? Is it the speed? Manufacturing ability?
Yeah. Look, we think about when we think about custom silicon, we always start with the customer. We don't kind of think about competition. We think about what does our customer want, and when we talk to customers, they want the broadest set of choices. They want, what are the different capabilities I can have? What are the different cost points I can have? What are the trade-offs between price and performance? And rarely do we see one solution being the best for every single workload of every single customer. And so we started our custom silicon journey actually on what we first built, we call our Nitro cards. And this was 10 years ago now that we built our first custom silicon.
The acquisition of Annapurna.
Annapurna was the company that we bought that kind of started our silicon team. And it allowed us to offload all of our virtualization functions. And so instead of using expensive x86 cores, we offloaded network virtualization, VM virtualization, storage virtualization, et cetera. So we could, and actually by moving all of that off of the processor, we got much better performance for customers. The customers can now get bare metal performance from an EC2 instance, and we got a much better security posture, which is very different than any of the other cloud providers that in their offerings. And this is still, I think 10 years later, this is still a pretty significant differentiator for us. And so then we said, we like that, we should go build a general purpose processor. And so these were built on ARM cores. And so we built a custom ARM processor called Graviton. And really Graviton 2, I think, was our first real kind of enterprise-ready general purpose processor, and it was a huge success. And actually, of our top customers, the vast majority of them have some, if not all, of their footprint on our CPU footprint on Graviton. And so we still, by the way, because of this choice piece, we still sell a huge number of Intel processors. We sell a huge number of AMD processors. But by having this option for this low cost, actually today, our current generation Graviton 4 processor, it's in absolute terms 20% faster than the best x86 processor you can get, and we charge 20% less for it. So it's a really great value proposition for our customers. And there's some workloads that still, count on special kind of Intel code or a custom design for Intel or AMD or whatever. And lots of customers still run on those platforms and get great performance and love running on those. So then we kind of fast forward, and about 5 years ago, we said we saw the rise of, at the time, AI, not Gen AI, but AI workflows. And we said, you know what, we think we should go build an AI chip to supplement our, and we're the first cloud in the world to offer NVIDIA in a cloud environment. And we saw that popularity, and we said customers may want an alternative to NVIDIA GPUs. And so we went and built our first AI accelerator chips. And that was Inferentia. It was kind of our first one, was just for inference. It was a really lightly powered chip, but actually our biggest customer was Alexa, as it turned out. And they were able to cut their inference costs. So when you go and talk to your Alexa device by something like 70%. And so that's when we were like, okay, we know we're onto something here. And so we built our first, we thought it was a training chip, and Trainium 1. We had a lot of learnings there. That was really to kind of get the software ecosystem to be able to write to these things. And now we're on our second generation in Trainium 2. Still, the vast majority of customers today run in NVIDIA in AWS. And we do believe that that's going to be true for a long time. They have a fantastic team, awesome product, great execution. And many of our customers really enjoy living in the NVIDIA ecosystem.
Is that a function of the CUDA mode?
CUDA is a fantastic software product. Absolutely. It's a great interface to writing to their chip. And so it's very good. And some of our largest customers really love the cost benefit trade-offs that they get from Trainium. And so folks like Anthropic and others are leaning in and using huge amounts of Trainium. We also use Trainium under the covers to power many of our Bedrock models in kind of a serverless inference world where customers don't know about the chips under the covers, and we can deliver that cost performance benefit to customers. And so we think that that choice that customers have is incredibly powerful, and we continue to add more and more choice over time to try to deliver more value to our customers.
So there are some rumors Google is maybe selling their TPU chips to third parties. Is that something that AWS would foresee, actually selling your custom silicon to third parties and letting them go build out infrastructure?
I would never say I have a general feeling. Would never say never to anything. Like, I think it's an interesting model, and someday we may do that. Today we get lots of benefits by only selling our chips in our own environment. It's actually a huge simplification if you think about it. Where when you build merchant silicon or you build something that has to go live in different environments, you have to build for a bunch of different server platforms. You have to build for a bunch of different data center environments. You have to build for a bunch of different, you have to worry about kind of firmware updates and other things like that. I have to build for exactly one environment. Like, it's in an AWS data center, it's an AWS server, it has an AWS network. And so that's a very simplified stack that there's a lot of complexity in going and selling third-party products, but I would never say never.
Okay. And I want to just touch on the Annapurna acquisition.
Yeah.
Because I think maybe it's slightly underappreciated outside of...
Not by me. I'm
for sure.
That's
what I want to ask about. Like, what did you see at that time, which was well before generative AI?
Yeah.
You kind of had the foresight to say, hey, we may need to build our own custom silicon. What does that look like? So talk about a little bit, what did you see in that team and what was that process like?
Yeah. Oh, look, one of the things that we loved about that team is they were very mission driven, and they were very kind of, they merged really well with the Amazon culture. We, at the time, as I said, we were kind of had this idea that we would move our virtualization into an offload card. And we looked in the out in the market of like who had something like this. And no one really had this idea, so no one made this product. But Annapurna was building a card that could offer virtualized networking to kind of it's kind of a high-powered kind of network card that had these cores on it. And we were looking at that product. It had these ARM cores that are kind of, you could just general purpose write stuff to them. Yeah. And we had this idea of we could also use that to offload the virtualization of EBS volumes that connect to EC2, so our external block storage product. And when we were talking to them about how that would work, and we kind of worked with them as a startup, and we got together with them and were co-designing how this would work, and we just really meshed with their team. They're incredibly smart, really forward-leaning, scrappy, and very customer-focused. And they thought big about that. And when we thought about like where's the big opportunity, we decided to acquire, and by far probably the best acquisition we've ever made.
Yeah. Definitely, I think one of the best.
And by the way, most of that team still works for Amazon today, 10 years later. So this is, I think one of the things we care a lot about when we buy somebody like that is like, do you care about the thing we're going to do? And what we liked is they wanted to go build a big business together with us and build AWS. And we were excited about that. They're excited about that. And they still work with us today.
Yeah, that's amazing. Okay, well, let's talk about the models that are getting loaded onto some of this custom silicon.
Yeah.
When you're looking at a new model and deciding whether you're going to serve inference for it, how do you make that decision?
Well, ultimately, look, at the end of the day, today you have to make trade-offs just because I think we're all scaling, but we would love to make every model available to customers so that they can use. I want customers to be able to choose from any of the very best models that they can use out there in the world. And I think there's going to be lots and lots of these models. There's only going to be a handful of these really large frontier models just because they're so expensive to build, but there's going to be lots of purpose-built models. And today, in fact, we just in the last month have probably added a couple of new startups to Bedrock, including like Writer, who makes some agentic workflows. We added 12 Labs, who does kind of understanding of video. And I think that there's more and more that we'll keep adding over time. We have a customer like Poolside that does coding specific models. We have a large kind of long tail Stability who continues to do interesting image and video generation. Luma AI, who has actually one of the very best video generation models, is super interesting. And so we continue to add models and support models in Bedrock, and I don't know that there's a limit of things that we want. We'd love to be able to support everybody, and just like we do in Marketplace today, where if you think about models are analogous to either SaaS applications or other applications, we'd love to make all of those all of those applications available in the AWS Marketplace, and we do today, from large applications like Salesforce and ServiceNow all the way down to small applications that smaller 1 or 2 person shops have built and put up there. And so that's our goal. And we would love to have every model out there in the world. Some of them have to agree eventually. And so not all of the models are available today. Some of them are proprietary to other locations. But in the fullness of time, we would love to make everything available.
And okay, so you had mentioned earlier when you're thinking about your engineering teams, you're finding that smaller and more teams, more kind of specialized teams are more effective. And when I look out into the model marketplace, there are some folks at OpenAI who are thinking an omni-model future is most likely, where there's going to be one giant model and it's going to rule them all. I tend to think it's more in the opposite direction, where we're going to have more specialized models for a lot of use cases. What do you think about that? And especially as you're thinking about which models to onboard into AWS and serve inference for them, how do you think about that problem?
I think that was, I think, the predominant view probably 2-3 years ago. And we long have had this view from the very beginning of generative AI that customers are going to want to use a lot of models. And I think if you look at most customer systems today, they are using a lot of models. A lot of times they'll use the large kind of premier model to do their kind of reasoning and planning, but then they'll farm jobs off to models that are really good at understanding their particular workflow that might have been custom tuned from a Llama model, or it might have been something that was distilled from an Anthropic model, or or a Nova model. And they think about trade-offs on cost, trade-offs on capability, and they're kind of this mixture of experts and various models that people are using. And so I think that is, I think we're at the early stages of that. We continue right now. We see a lot of enterprises who they're thinking, I actually want this model to deeply understand my data set. And so they're talking to us about, how do I do better fine tuning so that this thing really understands my data when it comes out of the, so when it's talking to customers about my particular, say, an insurance workflow, payment workflow. They know a lot about their particular area. They know a lot about their customers. They know about their workloads, and they want their model to know that. They want a generalized model for like the smart intelligence, but then they want to tune it with their own data. And then they want to trade off costs and performance for other specialized models, where something that comes and then maybe does image creation is actually a specialized model that's not just this one over here, this generalized purpose one. So we find, I just find that increasingly it's more and more of those. I also think, by the way, as we move into a more agent-focused world, I think the model is critically important, and it is the engine that kind of drives a lot of these things, and it's not the only thing. I think today, everybody is so enamored with these kind of model developers because it's so novel and so interesting. But I think we're quickly moving to a world where you're going to want an application that leverages that under the covers to go do something interesting. But you're going to think about scaffolding. You're going to think about workflows. You're going to think about custom pieces where you have a very kind of business specific thing that you're trying to accomplish, and you're going to layer on different pieces for that, because if you're somebody like ADP who's processing paychecks, that is a very different workflow than Netflix who's managing movie creation. Like, those are just different workflows, and you're going to want custom things that are going to think about that. And so I do think that as we talk to customers, most of the ROI that people are going to get from AI systems is going to come from these agent workflows that go and actually do work on their behalf. And I think those are going to require a whole different set of capabilities, where you're going to want to manage the memory of that system. You're going to want to manage interactions. You're going to want an audit log of what it's doing. You're going to want a whole bunch of pieces that are custom designed to what you're doing.
And so, as you're thinking about these models, open source versus closed source, you're serving Anthropic's closed source models. You have a plethora of open source models that you're also serving. Meta is kind of rumored to be moving towards the frontier. It's going to be closed, and then everything under that is open. Same with OpenAI. How do you think about the trade-offs between open and closed source? And then how do you also think about the partnerships between you, Anthropic, you, OpenAI, you, Meta?
Well, look, we want to partner with everybody. We have great partnerships with all of those folks. I think actually all of those models are mostly open weights. They're not open source. And the details of that, it's really just at some level, it's how much can I customize this model to my use case. And one of the benefits of something like Llama, and now there's others, and Mistral and others like that, is that you actually have a high level of customization. You can bring your own data. The real value is kind of bringing your own data to that model, enhancing it with the use case that you want to go after, and then having a custom workflow. I think whether it's, open weights that you can do yourself or through APIs where you can go and do distillation or you can do fine tuning to a, quote unquote closed source model, but you can actually customize it to how you want to do it. That's some of what you see we do with Nova, where you can't necessarily see the weights, but you can actually do a lot of customization. And it's where some people really like to use Nova today. And I do think that over time, everybody's going to want to customize their models. And whether people prioritize APIs to do it, whether they have professional services to go and do it, whether they have they just release the weights and let people do it themselves. I think that's just the difference between pricing and how much of that is a managed environment. But fundamentally, people want to customize these models, and I think all of the models are going to allow you to do that in some way, shape, or form.
So you mentioned Nova. You have a fantastic model. Do you see AWS building a truly frontier model to compete, maybe not compete, but to give another option to the frontier models from the closed source labs?
We continue to think that it's important for customers to have choice. And we think that we can offer some unique and differentiated capabilities with what we're building with Nova. And we're very excited about the things that we've done there. And we love the partnership that we have with a lot of the partners that are running in Bedrock, like the Anthropics of the world and others. And so we think that mix of models is going to be important for our customers. It absolutely is important today, and we think it'll be even more important over time. So it's an area that we'll continue to invest as we think we can offer kind of continued differentiated capabilities for our customers.
Okay. And how do you think, like, if you did decide to build kind of a competitive top tier frontier model, the relationship with an Anthropic or with Meta would change?
Yeah. Well, look, one of the things that Amazon is fantastic, I think that we've done a really good job at, that I'm proud of in AWS over the last 19 years, is building a partner ecosystem that we built trust with and sometimes compete with, but continue to go to and support customers together. And so, and I expect that that'll be true in this case. And so from the very beginning, we knew that people would be building on top of us. We would build capabilities. They would build capabilities. Sometimes those would be in conflict, right? Sometimes, whether it's great partners like a Snowflake or a MongoDB or other, there's hosts of others that compete. You look at the contact center space, and we have customers like Genesys that compete with our Connect offering, but they're fantastic partners of ours. And they build on top of us. And what we promise is that we're not going to disadvantage you in any particular way. We're going to give you great access to compute. We're going to give you great access to storage. We'll give you great access to the models. And we're not going to not give you a good price because you build something that's competitive with us. We'll give you a great price if you kind of have the right volumes and you're driving a great business, and our customers are interested in that. And we actually have built up great go-to-market motions with a lot of these partners as well. And so it's one of the things, by the way, it took us some while to learn how to do that, where we kind of got our field in the right way and thinking about how do we go build where we can be, fight tooth and nail against a competitor, and then have a different team that goes in and is the absolute best channel and partner for them in the world. And that's kind of the muscle that we've built up. It's important. And I think in this case, it will continue to be true.
Okay. And then as you think about model pricing, a lot of folks in the industry are saying, really, it's just a race to the bottom. Eventually, model pricing is going to converge on cost of silicon plus electricity. How does that factor into your calculus as you're thinking about infrastructure build out?
Yeah, I think that that's unlikely to be true. These models are not commodity today. I don't know why they would be commodity tomorrow. I think actually you can take the cloud. When we first started launching the cloud, everyone told us that it's only a matter of a year or two and these things are just going to be commodity. And they're not today. There's differences in availability. There's differences in features and capabilities. We have to continue to innovate to delight our customers with new price performance capabilities and other things that we build. And I think model providers are no different. I think if you ask customers today, do you consider Llama, Claude, and OpenAI and GPT to be the exact same commodity? They'd be like, no, of course not. They're different in a bunch of different things. And then you add in okay, are they commodity with the Luma models? No, of course not. Are they, again, you go down that, everything is different, and you say, and even the open models, right? I think if you ask people, are Mistral and Llama commodities? I think they'd say no. I prefer one over the other for different use cases. And so, look, I think everybody's going to have to keep adding new capabilities. You have to keep innovating. But I think there's a lot of value that's being created by both the the cloud environment that you're operating in, as well as the models that are building capabilities. I think there's a lot of value that's there, and then people are going to be able to make money from that.
Yeah. And last question on open versus closed source.
Yeah.
It seems like open source has been about 3 to 6 months behind closed source in terms of just total like benchmark performance. And do you see that trend continuing? It did feel recently with a few models coming out of China that were open source that were phenomenal, that maybe they're catching up and closing that gap. But do you see that trend of frontier closed source always being ahead?
I mean, at some point, there's no like inherent benefit of being a closed source or an open source model. It's just a choice. And so I think the China models open sourced the very best model they had, and they were behind. And I think they're probably, they're very good. And I think many of our customers love using DeepSeek. I think Qwen is a really good model. There's a number of those models that I think are quite impressive. It's just a choice. I mean, you saw OpenAI open source their model. It's, a smaller model than their kind of frontier GPT-5. Anthropic has chosen not to open source a model. Llama has chosen to open source all of their models. And so like, is Llama necessarily behind those others because they're open sourcing? No, it's just they happen to be, their model is not quite caught up to the best of the best, I think, today. And I think, but I think Meta has designs on doing that. Were they open source that or not? I have no idea. But there's no inherent thing. It's just kind of a value creation and where you think that from an enterprise, what you're trying to do and where you think you can capture value. So
yeah, it's an interesting way to
guessing where it lands is anybody's guess. You probably have a better guess than I do. I don't know.
It's almost like they're open sourcing because they're behind. They're not behind because they're open sourcing.
Yeah, I think that's. I think Llama may be a different story, but I think for some of definitely the models coming out of China, that's absolutely right.
Yeah. Let's talk about benchmarks. As you're looking to some of as you look into some of these benchmarks and models, and the models are really saturating many of these benchmarks, AMI 24, AMI 25, MMLU, like all of these benchmarks are just being demolished one after another. And we're at this point where we're getting single-digit percentage improvements against new models. Do you see that it's kind of a function of we just need different benchmarks, and what benchmarks do those look like? And how do you think about that?
Well, I think benchmarks are particularly good at measuring commodities. And like, if you're going to measure how fast an SSD is, like benchmarks are actually pretty good at that. You get some IO rates, you get kind of streaming throughput rates. You'd be like, okay, that's pretty much it. The more complicated the thing is, the worse benchmarks are. And so take in the early days of databases, it used to be like TPBC benchmarks that were like, okay, great, that's the great benchmark. I don't hear anybody, no database vendors talk about that anymore, because it's no longer like they're they've kind of moved past that benchmarking case, and so you have to test it for your use case. And I think that's probably where you'll move with models, is you just have to figure out which one works best for you, because the benchmarks are very good about doing kind of like, as soon as you can solve the things that you can come up with a benchmark, it ceases to be the interesting thing. And I think that we're rapidly approaching that, because it's actually quite easy to teach these models to be great at benchmarks, and it doesn't make them the best model.
Yeah. Okay. So then you personally, Matt, when you get a new model, you're testing it out. What does your personal benchmark look like? How are you testing these models?
I'm probably not the best test of all these things, because I think I actually think you have to do a bunch of things. It is my personal test is, I think, there's a lot of things that I like to use. And so I typically use them as part of applications when I'm kind of raw testing. I like it as part of an application. So you can think about research capabilities and kind of like, how well does something synthesize a bunch of thoughts, write it into a doc, and actually come back with something that's coherent. That's one of the things that I like to test, because I think it tests a number of those things, like how much can it find information, how much does it come up with different ideas for me, and how well does it interact. Some of it's just speed. That's my favorite one when I kind of want to test what a new model looks like. I tend to also like to test personally the implementation of some of these models too. So it's not just the model, but how well does it integrate in. I think one of our partners, as an example, sometimes don't even know which model they're using, but you use something like Perplexity. I think they do a really good job. They have a fantastic UI. They kind of let you know that they're thinking about when they're answering questions and doing work behind the scenes. And I think, increasingly that's just as important as the model. And so I think Arvind and team do a good job of kind of thinking about that UI and and building that into kind of perplexity searches. And so, I think it's not just about kind of testing pure benchmark type things, although they're interesting and they're fun and whatever. But really, sometimes it's about latency too. If a model's too slow, then that's not really going to meet the use case. And so I don't actually know if there's one particular answer for that, other than we want to kind of apply it to the various different things we're trying to do and see which one gives us better results.
Yeah, I feel like speed is underappreciated. Everybody talks about quality, but for the majority of my use cases, speed to the answer is incredibly important.
I think sometimes, I think today it's true. Most of the use cases that consumers have are real time, right? You're asking a question, you want an answer back. But let's say and so the speed will always matter to some extent. But again, I'll go back to the example of somebody like ADP. If you're having an agent that's going to go and process all of your pitchs and do all of those workflows, you actually care about accuracy a little bit more than speed. Because I don't know, you can do them at the end of the month. You probably have a couple of days to plow through all of those things. It's not like it has to be done like that.
Yeah.
Right? When it's coming, you can process those things, but accuracy is more important. And actually, one of the things that we just launched last week or a couple of weeks ago was the ability to take automated reasoning, which is kind of a math-based proof approach to a set of rules, and apply it to LLMs. So you can.
I made a video about it. It's so cool.
It's super cool.
Yeah.
And I think the combination of those two technologies is really interesting. And so that's an example where you're not trying for speed, you're trying for accuracy.
Yeah.
And in this case, a case like that, or a case of many agentic workflows, actually, you're okay with an asynchronous mode. You actually might be okay.
That's right.
Even in the coding world today, when you're vibe coding, latency matters, right? You're you want to type, you want it to come back. In an agent-focused world where you say, actually, I want you to go do this task, I want you to go do this task, I want you to go do this task, as you're working, it can come back an hour later, and it's fine, because you're actually doing other things, and you're working on other pieces. Then it comes back, and you look at it, and so that. Now, if it came back 3 weeks later, that would probably be too slow, so latency always does matter somewhat. But I do think that if you can get lower cost because it's asynchronous, or because it can think a little bit longer and give you better results, it kind of depends. And so the consumer use cases, real-time synchronous nature of them, absolutely.
Yeah.
I think there's a bunch of enterprise use cases where asynchronous results are okay.
How are we doing on time? 4 minutes. Yeah, I was about to ask.
Okay.
I'm flying through this. Let me just see. Let's talk about agents for just a couple minutes then.
Mm-hmm.
So I've used a ton of agents. I love using agents. I've actually applied them to my workflows quite a bit.
Awesome.
What are the use cases where you're seeing repeatable, accurate implementations of agents with positive ROI?
Yep. There's a couple ways that I would say. One is the coding use case that I've talked about a little bit, where I think that there's a great opportunity in agentic coding for developers to really unlock and kind of unleash their potential and go build more. And so I'm very excited about agentic coding. I think that's an area where we see a lot of potential, and we see a lot of customer potential. One of the problems that's been holding back agents is actually it's kind of hard to go build one. And once you have it, how do you operate it and run it in a sort of scalable manner? I think there's a bunch of kind of agents where you can build for yourself, right? Where you're like, hey, read my email and put it in this, whatever. Those are kind of simple rules-based agents or whatever. But when you think about an enterprise-wide agent, it's actually kind of hard to go manage. We launched a set of capabilities in Bedrock called Agent Core, which gives people these kind of building blocks to go build scalable, secure, auditable, measurable agents. And so there are things like a secure runtime environment that's completely serverless, scales down to 0, but allows you to run an agent not in a container or some sort of kind of non-secure boundary, but in a fully secure container that allows you to run it in that environment and scale it out to hundreds or thousands or however many of those you want to run. We also have built-in capabilities for short-term and long-term memory, so you can remember interactions that you're doing in both short and long-term. We have things like an agent gateway that allows you to do authentication with other agents, with other systems outside of it. You can actually do a hosted MCP server or any of these other kind of interaction cases, so that when you're interacting out there with the world, you have both a security boundary as well as an authentication boundary, and then built-in flows so that you can have things like observability that either you can put into AWS services or third-party services. And this is a completely open framework, so it works with any model. You can use it with Gemini models or OpenAI models or Bedrock models. You can use it with any sort of You, you can use it with any sort of frameworks like Strands, which is our own open source framework, or LangChain or anything like that. And when we see that when enterprises are kind of not building these agent workflows is because they had to build all this scaffolding. It was really hard. Now we see people flocking to it and really thinking like, okay, now that I have something like this, I think it's really going to unblock use cases. And so I see use cases for processing workflows. I see use cases for individual productivity. I see use cases for marketing use cases. We see use cases for sales use cases. There's really a whole host of these that we see people building across almost every single industry. Many of these still have human in the loop for many of these agent workflows, so that they're not kind of fully autonomous yet. But I see a path to where these can be much more autonomous things and really unleash people to do even more.
And so last question for you. I like to ask this of the AI leaders that I speak with. There's a lot of people who are quite worried about being automated away and just AI in general. What words of encouragement would you give them?
Yeah, I think this goes back to like, make yourself valuable. Like this is a value creation world, and AI and agents are not going to be valuable in and amongst themselves. They're going to be valuable in the way that they amplify employees and make you all more valuable. And so if somebody is great at marketing, we want that person to be able to do marketing and not be kind of in amongst the weeds of like putting campaigns together. If somebody is great at coding, that they're really great at building applications. You got to be great at building applications, not because you happen to know a particular language. And that's where people are going to have to learn those capabilities. But the more that you can think about solving customer problems, learn about how you be able to go learn some of these technologies and new tools, I have very little worry that jobs are just going to go away and it's just going to be a world of robots out there working.
Thank you, Matt.
Awesome. Thank you for sharing. It's really fun.
Yeah. Thank you.